wenz10. Today I will introduce Deadlock. We will go through its conception, problem, and solution. So, what is a deadlock? Deadlock is a kind of situation where a set of processes are blocked because each process is holding some resource and waiting for other resources. Those resources is also holding by some other processes. For example, here, thread 1 is holding object 1 and waiting for object 2. Thread 2 is holding object 2 and waiting for object 1. The two threads will be blocked due to the deadlock because none of the threads can give up their object and get new object to finish its program. There are some advantage and disadvantage of the deadlock. So when a situation there is a single burst of activity, deadlock will be useful, and there is no preemption need for deadlock. It is very convenient because those states can be easily saved and restored. It is good to enforce by the compare time checks. Also, you don't need to calculate the runtime since the problem will be solved in the system itself. There are also some disadvantages of deadlock. The deadlock delays the process, and also the process must know the future resource, what they need, and also because keep asking will need more often than the necessary. It doesn't allow incremental resource requests. Also, it inherent the preemption loss. Here are some examples of deadlocks in our real life. In the first picture, there is a crossroad in a traffic jam. You can see each road has many cars, and those cars need other road to take a turn. Since none of the cars can get out of its own road, and they need other roads to get off this crossroad, so none of the car can move out. Also, see these two angry kookaburras fight for meat. The bird want the meat in their mouths as well as asking for the meat in others' mouths. So they will fight all day without eating any meat. There are totally 4 requirements for creating deadlock. First is mutual exclusion. Since the resource is non-shareable, the resource can be only used by one process at a time. Hold and wait. The process is holding at least one resource and waiting for other resources. No preemptions. A resource cannot be taken from the process until the resource is released by the process itself. Therefore, you cannot just take the resources. Circular wait. Since the processes are waiting for each other in the circular form means there are at least 2 processes in the circular form. So there are also 4 ways to solve the deadlock problem. First is that you can just ignore deadlock. The operating system in this way assume the deadlock will never happen. Once it's happened, the computer will start to restart. You can just prevent deadlock from happening. Since there are 4 requirements, you can just simply kill one of the requirements. So the deadlock will never happen in this condition. You can just avoid deadlock. Operating system divide the process in different states. There are safety states and also unsafe states. Once the process go to unsafe state, the operating system just roll back until the state is be safe. So in this condition, there is no deadlock in the system. Of course, you can just simply detect the deadlock and recover it. So the system will get rid of the deadlock. Let's take a problem of deadlock, null in from the code. See, there are totally 6 processes, A to F. The process cannot be shared. So also there are 3 processes, P0, P1, and P2. P0 hold A, B, and C. P1 need D, E, and B. P2 need C, F, and D. So in this situation, there actually a deadlock happen. At this time, P0 hold A and B, asking for C. But C and F is already taken by P2. P2 also need D to finish its program, but D and E is taken by P1. P1 also need B to finish its program, but B is already taken by P0. So none of this process can go to their critical region. None of the resource can be released. It goes to a deadlock situation. So how to solve this situation? How to stop the deadlock from happening? You can just change the orders in some processes. You cannot change the process and or resource between the processes. For example, here, I changed the orders of the ABC process in P0 to stop the deadlock from happening. First, the P1 get B, C, and A. P1 only get D and E, because when it's getting B, B is already taken by P0. P2 will only get F, because DC is taken by P0 and P1. Therefore, P0 get into the critical region first. After P0 finish the critical region, it will release A, B, and C. So P1 will get B at this time. So once P1 get B, P1 will finish its critical region and release D, E, and B. So P2 can use the C and D resource to finish its critical region. Therefore, there is no deadlock in this situation. Thank you so much. Bye-bye.